Welcome to today's numeracy tutorial. Our learning objective today is to continue to find equivalent fractions. So far, we know that we can easily find equivalent fractions by drawing bars. We also know that we can use a fraction wall to help us examine equivalent fractions. Today, we will continue to develop our mathematical understanding of equivalent fractions by learning how to calculate them using multiplication and division. More of that to follow though. As always, we'll get ready for our lesson with a 5-question brain gym. Get ready to warm up. Here are your 5 questions. Pause the video now and have a go. Question 1 asks us to complete the stem sentence. We can see there are 3 bars. They have been divided into 3 parts to show thirds. We can see 2 whole bars are completely shaded and 1 part of the third bar. Altogether, there are 7 thirds shaded. Question 2 is an area question. The area is the measure of the space a shape takes up. It's measured in squares, so I will draw a shape with 8 squares. There are various possible shapes, but the important thing to note is they are squares, and all the squares must be the same size. There cannot be any gaps between them, nor can they overlap. Question 3 is a multiplication calculation. The product of 124 and 4 is 496. Well done to you if you calculated that correctly. If you didn't get that answer, go back and check to see that you remembered to include your exchanged tens. Question 4 gives us practice at identifying place values. The digit 5 in this case is in the hundreds place, so its value is 500, or it can be written 500s. As always, question 5 is our time question. Well, the minute hand is pointing past half past. In fact, it is 3 notches past the half past mark, meaning that it is 33 minutes past the hour. This makes the time in words 27 minutes to 4. The digital time always shows minutes past, so it's simply 3:33. Now we are ready to focus on our learning objective. Today we will learn the method of making equivalent fractions by calculating, rather than relying on a fraction wall or illustrations. We will use multiplication and division, so it's really important to have a very good recall of your times tables facts. Here we have a bar, and it has been divided into equal sections to show thirds, with one section shaded. Above the bar we have how many sixths are equivalent to 1/3. In order to compare thirds and sixths, we could divide each section by 2 to make 6 equal sections like this. Now we can see that 2 sixths are equivalent to 1/3. However, there is another way to divide our bar to compare thirds and sixths. If we take the same bar again, but this time we divide the bar horizontally across like this, then we have still divided each section by 2 to make 6 equal sections altogether. Sometimes this is easier or maybe a more efficient way of dividing bars to show fractions, particularly if we are working on squared paper. Could you use a similar method to find how many ninths are equivalent to 2/3? Pause the video now and have a go. We're comparing thirds and ninths, so we could divide each section by 3 this way to create 9 sections, or we could divide each section by 3 to create ninths this way. This way I only have to draw 2 lines, which is much more efficient. Either way, we can see that 2/3 is equivalent to 6 ninths. So far, we have used a range of representations including bar models, number lines and fraction walls to show equivalent fractions. My challenge to you is to use the different representations to show how many tenths are equivalent to 4/5. Pause the video and give this a go. Let's have a look at the bar model first. It has already been divided into fifths. We can shade 4 sections. To change our bar from fifths to tenths, I can divide the whole bar into 10 like this. Now there are 10 equal sections, and we can see that 4/5 is equivalent to 8/10. In a similar way, the circle has been divided into 5 equal sections, which means it is showing fifths. To divide the circle into tenths, we can divide each of the fifths in 2. So now, again we have tenths. And it's easy to see that 4 fifths is equivalent to 8 tenths. Moving on to the number line, we are showing fifths above the number line and tenths below the number line. If we find the position of 4 fifths, then we can see that this again is equivalent to 8 tenths. On to the fraction wall now. We again can see the equivalent fraction by finding 4 fifths and then drawing a line down to the green tenths bar. Counting along, I can see that 4 fifths is equivalent to 8 tenths. We have seen lots of ways that 4 fifths is equal to 8 tenths. Look closely at the numerator and the denominator. In earlier tutorials, I mentioned that there was a pattern between the numerators and denominators of equivalent fractions. What do you notice? Pause the video and have a think. Did you notice that to find the equivalent fraction, we can multiply both the numerator and the denominator by the same number? In this case, we can multiply them both by 2 to find the equivalent fraction. 4 multiplied by 2 gives us 8, and 5 multiplied by 2 gives us 10. 4 fifths is equivalent to 8 tenths. Here are 3 more pairs of equivalent fractions. Using what we now know, can you find the pattern linking each equivalent fraction? Pause the video and have a think. Francesca recognised that both the numerator and the denominator in the first equivalent pair had been multiplied by 2. 1 multiplied by 2 gives us 2, and we can see that 2 multiplied by 2 is equal to 4. So 1/2 is equivalent to 2 quarters. Flora has recognised that both the numerator and the denominator in this equivalent pair have been multiplied by 3. The numerator, 1 multiplied by 3 is equal to 3, and the denominator, 2 times 3 is equal to 6. So the equivalent fraction pair is 1/2 and 3/6. And finally, Drake has recognised that both the numerator and the denominator in this equivalent pair had been multiplied by 4. The numerator, 1 times 4 is equal to 4, and the denominator, 2 times 4 is equal to 8. The equivalent fraction is 4/8. To calculate an equivalent fraction, simply multiply the numerator and the denominator by the same number. To find this equivalent fraction to 1/3, we can multiply the numerator by 2, because we notice the denominator has been multiplied by 2. 3 times 2 is equal to 6. So 1 times 2 is equal to 2. This gives us the equivalent fraction being 2/6. We also know division is the inverse of multiplication, so we can also find the equivalent fractions by dividing. You will notice the denominator, when it is divided by 2, is equal to 3. So the numerator, when it is divided by 2, is equal to 1. In the next pair of equivalent fractions, we can notice that the denominator has been multiplied by 3 to get 9. To calculate the missing numerator, I must also multiply the numerator by 3, and that will give us 6. The equivalent fraction to 2/3 is 6/9. Here are 4 examples of equivalent fractions. Can you use the method of multiplying or dividing the numerator and the denominator to find the missing digits? Pause the video and give this a go. In the first example, we can see quarters have been changed into 16ths. To do this, we multiply the denominator by 4. So to find the equivalent numerator, we also need to multiply 3 by 4, and that gives us 12. So the equivalent fraction is 12/16. In the second example, the numerator has been multiplied by 3, so the denominator must also be multiplied by 3. 9 times 3 is equal to 27. So 2 parts of 9 is the same as 6 parts of 27. In the third example, we can see the inverse calculation division was used. We can see that 14 has been divided by 2 to give 7. So 20, the denominator, must also be divided by 2, and that will give us 10. In the last example, what could make the equivalent fraction by multiplying the numerator and the denominator by the same number? Well, we could multiply the numerator and the denominator by 2, and that would give us an equivalent fraction of 6/14. But there are lots of equivalent fractions that I could calculate. Remember, so long as we multiply both the numerator and the denominator by the same number, we will always get an equivalent fraction. So I could multiply both 3 and 7 by 12, getting an equivalent fraction of 36 parts of 84. Or if I multiply by 100, I would get an equivalent fraction of 300 over 700. Now it's your turn to use your knowledge of how we calculate equivalent fractions using multiplication and division. Examine these fraction cards and match the equivalent fractions. Pause the video and have a go. How do you think you got on? Let's examine these fraction cards together. Knowing that equivalent fractions are calculated by multiplying or dividing both the numerator and the denominator by the same number, I can identify that 1/3 and 3/9 are equivalent. The numerator 1 has been multiplied by 3, as has the denominator. 3 multiplied by 3 will equal 9, so 1/3 and 3/9 are equivalent. The next pair of equivalent fractions that I can identify are 2/7 and 10 over 35. I recognise that both the numerator and the denominator have been multiplied by 5. This leaves the last equivalent fraction pair being 6/15 and 2/5. This time, instead of multiplying, I notice the inverse calculation, division. 6 divided by 3 is equal to 2, and 15 divided by 3 is equal to 5. A big congratulations to those of you who completed that challenge successfully. You are most definitely on your way to becoming fraction whiz kids. So far, we have looked at calculating equivalent fraction pairs by multiplying or dividing. Let's take a look at these 3 fraction cards showing equivalent fractions. Can you use related multiplication and division facts to find the digits hidden by the ink splotch? Pause the video and have a go. Let's see how you got on. I first noticed that I have 2 numerators that are linked with a multiplication fact. 3 multiplied by 2 is equal to 6. To find the missing denominator on this equivalent fraction, I multiplied the denominator by 2. In this case, 15 multiplied by 2 is equal to 30. I could now use 6 over 30 to find a related multiplication or division fact to find the missing numerator. But instead, I'm going to use the original fraction that we were given. I recognise 3 over 15 is linked to the third fraction by a division fact. 15 divided by 3 is equal to 5. If I divide the denominator by 3, I must divide the numerator by 3, so 3 divided by 3 is equal to 1. We have calculated that 3 over 15 is equivalent to 1/5. But also remember, it is equivalent to 6 over 30. Have a look at this question. This time there are 4 fractions that are equivalent. Just as before, use related multiplication and division facts to find the missing digits. Pause the video and have a go. Well, how do you think you got on? Let's look at this together. We can see that we're given 2 numerators side by side, 6 and 9. Can we see related multiplication facts between the 6 and the 9? No, we cannot multiply 6 by a whole number to get 9. How about 8 and 20? Is there a whole number that we can multiply 8 by to get 20? No. However, 6 and 3 are related to a division fact. If we divide 6 by 2, we get 3. Remember, we need to do the same to the denominator, so 8 divided by 2 is equal to 4. We can now say that 4 multiplied by 5 will give us 20, so 3 multiplied by 5 is equal to 15. And then if we return to the first fraction, 3/4, we can see that 3 multiplied by 3 is equal to 9. So therefore, 4 multiplied by 3 is equal to 12. That brings us to the end of today's tutorial. Now that you have a much better understanding of how we can calculate equivalent fractions using multiplication and division, why not have a go at helping Greg explain his puzzler? Greg is correct in saying that these two fractions are equivalent, but he doesn't know why. Try to explain it to him by identifying the patterns between the numerators and the denominators. Here we can see that 6/10 is equivalent to 3/5. We discover that by dividing the numerator and the denominator by 2. We also have shown that 9/15 is equivalent to 3/5. We just divided 9 and 15 by 3. You will get lots of opportunities to practice calculating equivalent fractions. And with practice, you'll become a dab hand at this. It's time for you now to go and complete your independent task. But remember, you can always come back for another look. Good luck!